Hi, hi. Today I am going to talk about the filter driver. So, what is filter driver? Filter driver is a driver which actually sits between the main driver, which is interfacing the user application and the device. So, what is the purpose of filter driver? Filter driver actually either adds value to the driver, performance, or it just monitors it. Okay, monitor the behavior. Okay, what is coming from the user space, or because actually there are many. There are many drivers actually whose source code you do not have, just the binary you have. To understand the performance of it, actually, what you are getting, if you want to debug, you can use the filter driver. That will help you. Okay, so today I am going to talk about the filter driver, keyboard filter driver. So what happens actually that whatever you type, basically, how does it work? You can use the filter driver to capture what is typed. Okay, and today I am going to discuss about it. One thing you should know that ideally, if you see the picture or the stack, you will always see that filter driver sits in between the drivers, or it is connecting with the driver and then device. But in reality, basically, a filter driver has to get connected with the device, and then actually, of course, it has to connect with the other driver as well. But the device actually, the driver, what you call it, is actually a device. Okay, so now I'll go and show you the what do you mean by device. So in this for seeing actually what all devices are available, and how can you map these certain how can you hack certain driver device. Actually, you have to open the WinObj tool from systeminternal.com. You can easily find, even I have already shared it in the same location. So if you see under device, actually you have the keyboard, right? Keyboard class driver, keyboard class 0 device. So basically, whatever you type here, or whatever whenever PS2 or any input, whatever it gets into Windows, it uses the keyboard class 0. So objective of this video is to show you how to connect to the device. Okay, if you are seeing this video for the first time, I request you to look at the other videos I prepared, and that will give you clarity. Actually, what is actually the driver entry, or what is unload function, or what is measure function. I have already explained those things in. So as I said, actually, that driver entry and measure function, these are already explained there. So I'll not spend time right now. But here, let me explain you that for all the measure function except the read, I'm using the dispatch paths function pointer, and for read, actually, I'm using this dispatch read. Okay. But how I'm going to use, I will talk about it in the next section of the same video. Here the most important thing is how can you attach the device. Attach this particular driver with the keyboard class driver. So let us actually go into this code. So this is attached device. So here first thing is actually target device, actually, to whom I am going to connect the this particular device what I am creating right now. So this is the location we already saw in this as well. So the location is keyboard class driver under slash device and keyboard class 0. Okay, so here the first thing I have to create my own device, right? To create, actually I'll use this function IO create device, and I'll pass the driver object and then the device extension. This is very important because actually this is going to be the extension of the device keyboard, right? Because it is a filter driver. Now this is a custom structure, so you have to define it as well, that I am going to show as well. And then it is a keyboard kind of device, and then this is the whatever the actually device will be created will be assigned here in this keyboard device. So let's understand the keyboard extension. Okay, this is the device object, so keyboard device, which is ours, and this is extension. So you see this is a device object and it is a lower keyboard device. So this is how we have to do. Once you want to create extension, you have to do this way. But apart from only one device object, you can have threads and other things also to have the additional operation, but it is for demo purpose, so I'm not going to use it. Anyways, once actually your device is created, needless to say that actually you have to check for failure case as well. Now in this keyboard device what you created just now here, you have to do device object buffer IO. So what does it mean? That see, there are many ways you can copy a data from user application to kernel. Okay, and see, many times you cannot guarantee that your user space is active user space user process right now. So what we have option that actually we will create a buffer inside the kernel address space, and then we will what we will do actually, that the IO manager will copy whatever the content, if you are doing a write operation, into the kernel address space, this particular buffer, the IRP. Actually the IO manager actually creates the IRP, right? And then the IRP actually it creates the system buffer. The system buffer size is of the same size the user is requesting. So the same buffer will be duplicated into the kernel address space, and then what the IO manager will do is that it will give you the it will first actually give you the virtual address space, and then if it is a read operation, then IO manager will create a IRP system buffer, and the system buffer will point to this buffer. Okay, and whenever actually driver wants to access it, it can directly use the system buffer and use it. This system buffer will be resident non-paste pool. So this is about this. Otherwise you have other option also, like direct IO. If you are doing direct IO, then actually the user space buffer will be locked, and then you can use it once it is in active mode actually. So if it is not in active mode, then actually you cannot. So there may be a delay, but the safest way is that when you copy the data into kernel space and then you use it, because it is always reliable. See, when you actually clear this do device initializing, means actually you are now going to start. So the first thing you have to do is that you have to clear the device extension, and then the final step is that you have to IO attach device. So it means that actually this is the lower keyboard device which you want to connect with the target device here. Okay, so this way actually you have to attach. This is the final attachment. So here actually the attachment happen with your device and the actual device, and whatever is actually you would like to access, you can access through this. Okay, great. So if it is unsuccessful, we have to delete it. So I'll not explain dispatch path and pass and dispatch read here right now, but I'll show you the demo actually how does it work when you are just attaching the device. So for that, the first thing you have to do is that you have to open this loader as usual. So the first thing I'm going to do is to compile the source code. This succeeded, right? Now I'll go there and load the driver. So this is actually 9:35 and the time is 9:35 in the system. Okay, once I'll do one thing, I'll rebuild it. That will give more confidence because the time is different. Now see here, so I'll browse it now and you can see the date and time it is updated, and I'll open it. The first step, registered service, so already like this. Okay, before doing anything, let us open the another tool, device tree. So here you can see our driver. So this is again from the OSR only, so you can get it same location, it will be available. Okay, so which driver we are working on? Keyboard, right? So this is this one, right? Okay, now what will happen when we will start the service? So what we are doing, we are attaching our device there. So start now. So it is started, completed, and we can see the same thing in our debug view, right? So whether it is attaching or not. So I'll first stop it and then I'll start the service. So this is stop, unload it, and I'll clear it first, and then I'll start. So if you see, driver is loaded, attachment successful. Now it is successful. So it's now what, there is nothing attached, right? Now I'll refresh it. So view is there, refresh. So once I'll do it again, it will try to see what all driver devices are there. So this is KBD device class. Okay, now you can see we have attached, right, our driver, wind filter driver demo. You can see I didn't put any name, so no name is also there, and it is buffer IO. I already mentioned it. So far I think you are clear with how to load the driver and how to attach the your own device or device driver with any of the driver which is already loaded. Right now the next step is actually how to capture the events. Right, so if you see here, I have already set actually dispatch pass and dispatch read. So let us actually go into dispatch pass. If you see actually, this is very simple implementation. So here what is happening, that we are getting the IRP and I am setting this IRP to the next location. What does it mean? What is stack location? Stack location, actually what happens, if you see any IRP, in every IRP there is a memory defined for every driver attached to it. Okay, and since actually our here right now our driver, I mean this IRP is for our driver, but where we want this where actually we want actually our IRP should point to, we want it to point to the lower KBD device, right? So what we will do first, that actually this IRP location will move to the next lower level stack location. So you see, lower device, keyboard device, and this one both is attached, but for this there is no driver. So whatever the IRP we are getting, we have to pass it to the next layer, and once you point to the next, then you have to call the driver. So technically it means that you are passing the IRP which is now pointing to the lower KBD device, and then you are passing this IRP to lower KBD device, which is nothing but device object. I hope you are clear here. Okay, for any other apart from read, we are doing the same thing. Okay, the next most important is read. Here what we are trying to do in this filter driver is that we will read every keystroke and then we will display. Okay, so here we are monitoring all the keystroke, but at the same time you can modify, you can do whatever you want, you can change the system buffer, you can do everything whatever you want, so that basically you can play with the keyboard main driver. In the similar way you can play with any other driver as well. Okay, so let's go to the read function. So in dispatch read, what first thing you have to do, you have to point the IRP to the next stack location where your actual device is. Okay, and then you have to call the IO set complete routine. So what it do, actually it takes this IRP basically, which is already pointed to the next location, and then call the read complete function, and then it has some other parameters also, invoke on success, invoke on error, invoke on cancel, all these things. So you can actually set to true or false. If you want intimation, then fine. If you don't want intimation, then also fine. It is up to you. It is just for demo purpose, so nothing wrong, nothing right. So let's go to the read complete here. This is the standard template. So here I am doing the unreferenced parameter, because otherwise it will give you a warning, and if you have set actually your warning to be converted to error, then it will give error as well. Here we have P keyboard input data. So and in these keys we are just actually copying the data from the system buffer of the IRP, which actually passed right now. Okay, and these key flags are there basically, which will indicate whether it is key up, down, or key E0 or something. So basically from where I got it, all these things, right? That is your question. So this keyboard input data structure, if you see here, it has actually some, it is a structure basically which has make code and flags. So what is make code? Actually make code actually specifies the scan code associated. So whatever actually you do, you will see the scan code. I mean, if you want to know scan code in Windows, you can see it here. And this is for keyboard scan code, right? So basically for every keys there is a scan code, right? Okay, so it is basically ASCII, but it is for Linux right now, but for Windows also the similar is there. Exactly, just okay, I will tell you. So you can actually see this scan code for every ESC. There is a scan code for everything, right? So that you should expect when you press anything. Okay. So let me explain this piece of code, which is little confusing here. First thing, you have to get the information which will actually give you the size of the data you have received, and then this is a structure number will show you basically the how many data you have to show. What I mean that suppose if you are pressing one key, right, so only buffer for one key will be available, right? And to know actually how many keys actually got pressed, then you can only know if you divide this information by this size, and that will give you the how many keys got pressed. Okay, great. So if it is success, then you have to run this for loop, which will show you how many scan code you have got. And this is very important here. What we don't want that actually, if pending return is set, then we have to mark that particular IRP as pending. So it is possible directly. I mean, the read function is not actually, handling all the IRP, is not able, could not handle all the IRP while. So there will be many IRP which will be in pending state. So what we have to do is that actually we have to see if this IRP is in pending state. If it is yes, then actually we have to mark that IRP as pending. And in additional, for additional safety, actually we have actually pending keys here. So here once this function gets executed, read complete, then actually we will reduce it to minus. So this is a pointer just, and unless it is not, actually we will increment this pending keys. So this will ensure that it is synchronized correctly. And once actually this the reading part is completed, then what we have to do next is that we have to send this IRP, and we have to send this one to our keyboard device, and we have to return. I hope this is clear, and also let me explain you about the unload function. So while unloading, you have to first detach the device, right? This lower keyboard device, first you have to detach, and then you have to delete your keyboard device. I think I am clear with with the explanation of the source code. For additional question, you can always WhatsApp me. Okay, let me please show you the demo now. As I already told you, actually the driver is already loaded here, right? So just to be double sure, we'll check whether it is already attached also or not, or driver is attached or not. So right here it is attached. So we can close now, or we can leave it like this. Now we have the debug viewer, right? So I'll type actually something. So the moment if I'll type say A, it is showing the scan code. So what is the scan code of A? A scan code is 1E, right? Here what we are getting is 1E. So key down, key up. So there are two there are two elements got executed, right? In the similar way, if I will press R, then it is the corresponding right there. And in the similar way, you can press, you can see all the keys, right? So this is actually keyboard filter driver. Now the moment you stop this service, now what will happen? It has something pending here so far. So what we have to do, we have to press one keys, so it will be successful. Yeah, thank you so much. I hope it helped you to understand the filter driver, and I believe if any problem is there, you can always contact me, or you can refer a book. Actually, I'm going to share with you as well. That book is actually good enough, and that has explanation of the code what I have written as well. Thank you so much. Bye bye.